Okay, so let's have a look at the Junior Certificate Higher Level Maths Paper 1, 2019, question 10. So we have, in this particular case, we have to draw each of the following two functions in the domain x is greater than or equal to minus 2, less than or equal to 2 for x being real, and show your working out. Okay, so we've got to draw this quadratic function here. So let's do a little table here. So I'm going to do x, then the function is 10x minus 4x squared, got y, and I'm going to put the points here. So the x's go from minus 2, minus 1, 0, 1, and 2. So we're going to do these points. Now all we've got to do is put these x's into the function and see what the y's will be. So in other words, we're going to do 10, we're going to put a minus 2 in here, then we're going to put minus 4, we're going to put the minus 2 in here and square it. Now if you do this, you get y value, and the y value in this case is minus 36. Let's just do that in a different color here, minus 36. So the point that we're going to plot first is minus 2 minus 36. So minus 2 minus 36. So here's minus 2 here, minus 36, this is minus 30 minus 40, so this is minus 35. So minus 36 is somewhere here. Okay, so let's look at minus 1 then. So you're going to write down 10 minus 1 minus 4 times minus 1 squared. So again, you can do this on your calculator, or maybe I'll just do one of them. So you got 10 times minus 1 minus 4 times minus 1 squared is what we've got to do here. So 10 times minus 1 minus 10. Now remember, you've got to square first here. So minus 1 squared is going to be 1. So you end up with minus 10 minus 4, which is minus 14. So you can do each one of these like this, or try it on your calculator either. So we end up with minus 14 here, minus 14. So the point here is going to be minus 1 minus 14. Okay, next one, we have 0, so that's usually an easier one to do. We've got 10 times 0 minus 4 times 0 squared. That's just going to give me 0 here. So that'll give me 0 here, so I'll end up with 0, 0. Let me just do this other point first as well. Minus 1 minus 14. So this is minus 10, this is minus 15. So minus 14 is around here somewhere. And then we've got a 0, 0 as well. Okay, so let's do another one. We got 1 here, so it's 10 times 1 minus 4 times 1 squared. So if you do that, you get 10 minus 4, which is just 6. So we're going to end up with 6 here. So we end up with 1, 6. So 1, and we end up with 6. This is 5 here. So 6 is about here. 2 then, finally, we'll just do 2. So 2 is 10 times 2 minus 4 times 2 squared. Well, 2 squared is 4, 4, 4, 16. So it's 10. Let me just work that out actually. I might just do that here just to be sure. 10 times 2, oh yeah, minus 4 times 2 squared. So 2 tens, 20, minus 4 times 2 squared is 4. So you end up with 20 minus 16, which is 4. So here we end up with 4, so we end up with 2 and 4. So 2, 4 is here. So you've got to join these up. So again, I'm doing this freehand, but let's see how we do. Okay, not too bad. So that's the first one drawn, and we've shown how we worked it out here. Okay, so let's have a look at the next one then. Now this one here is an exponential function. Y is equal to 3 to the power of x. So let's do the same thing here. So we have, again, we'll write down x. We've got 3 to the power of x. We've got y, and then we have our points here. So our x was minus 2, minus 1, 0, 1, and 2. So we've got 3 to the power of minus 2. 3 to the power of minus 2. So if you think about that, you have 3 to the power of minus 2. From your rules of indices, that's just 1 over 3 to the power of plus 2, which is 1 over 9. So our y coordinate here is 1 over 9. So our point then is just going to be minus 2 and then 1/9. So minus 2 and 1/9. So 1/9, this is 1 here. So 1/9 would be very close to the x-axis here. So it's somewhere down around here. Right, so let's do the next one then. So we have 3 to the power of minus 1. Well, again, that's just 3 to the power of minus 1 from your rules of indices. 1 over 3 to the power of plus 1, or just 1/3. So we have 1/3 here. So we have minus 1 and 1/3 here. So minus 1 and 1/3, a little bit higher. It's just going to be somewhere around here, let's say. Now let's put in 0. So 3 to the power of 0. Well, anything to the power of 0 is just 1. So we have 0, 1. So that's going to be here. Okay, next one we have 3 to the power of 1. That's just 3. So that's going to be 1, 3. So 1, 3 is going to be exactly here. And then finally we have 3 to the power of 2. So that's 9. And that will give us 2, 9. So 2 and 9 is going to be here. So this is what our curve will look like. Okay. Okay, so that's our second function. Okay, so that was the first question. Let's have a look at the second one then. Question 11 here. It says solve the following equation. Give your answer in the form m over n, where m and n are natural numbers. Okay, so our solutions are going to be fractions. Let's write that down then and see what we end up with. 3x plus 5 over 2 plus x minus 4 over 3 is equal to 16. Now normally what I like to do here is add these two fractions first. You could, another way of doing this is to multiply across by 6, multiply everything by 6. Might be an easier way of doing it actually, but let's add them first anyway and see where we end up. So common denominator is 6. 2 and 3 both divide into 6. So 2 times 3 will give you 6. So we had to multiply this 2 by 3 to give 6. So I got to multiply the top here, 3x plus 5 by 3 as well. You got to multiply 3 by 2 to give you 6. So you got to multiply the top part here, x minus 4 by 2. Okay, so next line then, just multiply this out. So you've got 9x plus 3 5s 15 plus 2x minus 2 4s 8. And again, that's over 6. That's equal to 16. Okay, next one. 9x plus 2x, 11x plus 15. 15 minus 8 is just 7. And that's over 6 is equal to 16. Now we're just going to get rid of this 6. Now we're multiplying across by 6. As I say, you could multiply each of these terms by 6 at the beginning. But let's do it here anyway. Multiply this side by 6. So really what I'm doing is this. Multiplying this side by 6 over 1. Multiplying this side by 6 over 1 if you like. So they will disappear, or they'll give you 1 anyway. And on this side then you just end up with 11x plus 7 is equal to 6 times 16, well 6 6 is 36, carry 3, 6 1 6 7 8 9, 96. So here we end up with 11x is equal to, well, subtract 7 from both sides, that gives you 89, and then finally divide by 11, so you get 89 divided by 11, 89 over 11. So it said give your answer in the form m over n, where m and n are natural numbers, so we have it in the form of a fraction m over n, and both m and n, the numerator and the denominator, are natural numbers, so that's fine. We can't simplify this any further. Okay, let's have a look at question 12. So we have a squared minus 16n squared, and we've got to factorize it. Well, you should recognize that this is actually the difference of two squares, so we can rewrite it as 4n squared. 4 squared will give me 16, n squared will give me n squared. So the rule here is you take the first one, first term, plus the second term times the first term minus the second term, and that's it. We have it factorized now. Next one, factorize this quadrat. Oh no, wait now. One of the factors of 8 squared plus 45x minus 18 is x plus 6. Factorize. Okay, so it's only asking us to factorize this. So 8x squared plus 45x minus 18, we've got to factorize this. So there are a number of ways of doing this, but normally what I like to do is just look at it and just work it out. So 8x squared, well, you've got to look at 8 here. You've got a number of options. You've got 8 times 1, you've got 2 times 4. So let's try 8 times 1 first. So I'm going to do let's say x times 8x here. And now we've got to look at 18. 18 can be 1 times 18, 2 times 9, 3 times 6. Now you've got to decide which pair is going to work. So which pair can we put in here that will also give you 45 when we do the addition version of this as well. So I know that it's going to be 3 times 6. So let me just put this in here and just show you how it works. 6 times 3 will give me the 18, and now I need a minus 18, so I need a plus and a minus. So which one is going to be plus? Well, the higher one, the bigger one, has to be plus. In other words, when I check this, when I multiply this one by this and this one by this one here and add them, the bigger one has to be plus. So 6 eighths will give me 48. 3 times 1 will give me 3. So this one here has to be plus, this one here has to be minus. So let's just run through the checks here. X times 8x will give me 8x squared. Plus 6 times minus 3 will give me the minus 18. What about when I look for the middle term here? Well, plus 6 times plus 8x will give me plus 6 eighths 48x. Now this one here, x times minus 3 will just give me minus 3x. So if I add these two, I do get 45x plus 45x. That is the middle term here. So this is my answer here at this stage. This is my answer here. Okay. Let's see, does this work? No? Okay. We'll leave it where it is. So we have 6x plus 6 times 8x minus 3. And that's this one here factorized. Now they told us that one of the factors is x plus 6, so we can see, if we were looking for one of these pairs to actually put in here, we can see that one of the factors has to be x plus 6 anyway. So we knew we have to use we knew we have to use this pair here anyway. Okay, so let's move on then. Write down one quadratic expression in x other than x squared plus 45x minus 18 that has x plus 6 as a factor. Well, we can take, there are a number of different answers to this. If x plus 6 is a factor, it's asking us to write down another quadratic expression. So you can pick anything really. let's say x minus 5 for example. If we multiply these two out, x times x will give me x squared, x times minus 5 minus 5x, 6 times x plus 6x, plus 6 times minus 5 minus 30. So when I add these, x squared minus, so it's actually going to be plus x minus 30. This here is another expression where x plus 6 is a factor. In other words, if we were to work backwards here and factorize this, we would just end up with x plus 6 times x minus 5. We'll end up back here again. So this is another expression with x plus 6 as a factor. Give your answer in the form ax squared plus bx plus c, where a, b and c are real. So a here is 1, b is minus 5, and c is minus 30. So you may get a different answer, but my answer here anyway is x squared plus x minus 30. Okay, now part C here. Show that 2y plus 3 is a factor of 2y cubed. So we've got 2y cubed minus 9y squared minus 28y minus 15. So show that this number 2y plus 3 is a factor of this. In other words, it divides in evenly with no remainder. Now that's what I'm going to do. I'm going to do some long division here. So let's take the 2y plus 3 and divide it in. So 2y into 2y cubed will just give me y squared. So in other words, 2y cubed divided by 2y. Well, 2 will divide into 2. Y cubed divided by y is just y squared. Subtract the 2 powers here. 3 minus 1 is 2. So now you multiply the y squared by these two, write the answer underneath here. Y squared times 2y is 2y cubed. Plus times plus is plus 3y squared. Put a line underneath, and what we're going to do now is subtract these two. So minus 2y cubed plus 2y cubed will give me 0. This becomes a minus here, so we've got minus 9y squared minus 3y squared. That's minus 12y squared. I'm going to bring this down, so that's minus 28y, and start all over again. Divide the 2y into the minus 12y squared. So it's going to be minus anyway. 2 into 12 is 6. Y into y squared is y. Now multiply this by minus 6y. Write your answer down here. So minus times plus is minus 6y times 2y, 12y squared. Minus times plus minus 6y by 3. 3 6s 18y. Same thing again. Subtract. And let's see, this minus minus becomes a plus, so this will disappear here if you like. Minus times minus is plus, so this becomes a plus. So minus 28y plus 18y, so that will just give me minus 10y. Take the minus 15 and bring it down here. Start all over again. 2y into minus 10y. It's going to be minus anyway, and 2 into 10 is 5. And we have a y here and a y here, so they'll just cancel. So minus 5 times plus 2y is minus 10y. Minus times plus is minus 5 times 3, 15. Put a line underneath and again subtract. And you can see here that if we subtract these, we do actually get 0 remainder. So this is showing that 2y plus 3 is a factor, or does divide in evenly into 2y cubed minus 9y squared minus 28y minus 15. So it divides in with no remainder. Therefore 2y plus 3 is a factor of 2y cubed minus 9y squared minus 28y minus 15. Okay, so that's part C, and actually that's it for these questions.